other than it depends on how many people do not show up today. Because I can only move people into the whether see what the policy is, because sometimes they don't want too many extra students, and other times they do want extra students in the class. It depends on. See, the college gets funding from the state for a fixed amount of students per year, I guess per academic year. So that means we have a certain number of students in the entire district that will be quote unquote funded by the state. In other words, they're all the expenses will be paid for by the state, in addition to your whatever fee you pay to the college. The additional students that I admit into a class or the college as a whole are basically what we call unfunded students. So the college has to dig into its own pocket to pay for the balance, basically. But sometimes they're willing to do that, like 2 or 3% over enrollment, which means 2 or 3% of students will be unfunded by the state. And sometimes they would do that because the state may be looking for growth. Okay, and eventually over time the state will reimburse colleges that experience a rapid growth, and that's why they would sacrifice a little bit to get the growth money later on. But I'm not sure for this semester whether we are going for growth or whether we want to just cap it at the funded student level. So I have to talk to the dean to find out. One thing that I can do is, for people on waitlist or beyond the waitlist, in order for you guys to kind of participate in the class, have access to the material and so on, I can manually add you to Moodle, so you can still turn in your homework assignment, you can still read the text and so on, but you won't be officially on roster until I actually add you to the roster. Okay. So to do that, do not come after me after class. Instead, send me an email and state that you want to add to Moodle for the PM class of cisp300. So I'm going to give you my email address. It's ertak2013fall@gmail.com. And you want to mention a few things. You want to add to cisp300, and it's the PM or evening class. You want to mention your first name, and your last name, and your student ID. This way I'll be able to create your account in Moodle so that you can at least participate in the activities and the other stuff. But as far as actually adding you to the roster, it depends on the drop situation. I think this class is really full even at this point, so we'll see what happens. Any questions? Okay. If there are no questions, don't forget to initial your name on the roll sheet, and we'll go ahead and get started with the lecture. Is the fan helping at all?
Yes.
Other than it's contributing to the noise level?
Not back here.
Not back there.
So
I can crank it up a little bit, but I don't want the front students to
feel
be.
it. I got it. Yep, I feel it.
You feel it? I don't want it to be too noisy, because otherwise the students in the front, cannot hear me because it's closer to those students. So I kind of have to balance it a little bit. Is that okay? Can you guys still hear me? When you're close? Okay. Sorry? Oh. I can talk behind the fan like this.
Exactly.
La.
I used to do that when I was a kid.
I still do it. Okay, I forgot to turn off the ringer of my phone, so I'm gonna turn it off right now because I get notifications whenever I get emails, so it's gonna.
When we get email security?
Sorry?
When we get to call campus security?
Well, since I remember to do it, you guys did not warn me. It's okay. All right, so we're gonna get started. This is the PM class, and last time we were still on this topic. It's a new tab. browser setting of this computer is different from my other computers, so the font looks actually kind of funny. It's kind of pixelated for some reason. Last time we talked about building a house. You have a piece of land along Highway 5, and you have an infinite amount of money to build a house. So we were talking about the process of how would you build a house, how would you design a house, and get the house checked out by an engineer, make sure everything is safe and it can be done, and you can specify the right material, and then you have your contractors to actually build a house. And then you have the inspectors to come in and double check and make sure that the house was built to your specifications. Do you still remember kind of vaguely that portion? Okay. What I did not mention is, as a developer or someone who's going to write the programs, there are certain challenges to in that particular occupation. So I will start with the simple ones, and then we'll move to the more difficult part of why some people cannot become developers. The first part is when you become a developer or a programmer, you really have to understand the syntax of a programming language, which is basically the grammar of a programming language. Those are the rules that you have to play by in order for the compiler or an interpreter to understand what you want the computer to do. We use grammar on a daily basis. Okay, all natural languages have some kind of grammar. Some are more lenient, others are more strict. But on a daily basis, if I make a mistake, like if I say, oh, on Tuesday I teach you guys da 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 da, instead of on Tuesday I taught you guys da 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 da, you might catch that mistake and it just doesn't sound right. But for the most part, you will still understand that I meant what I did on Tuesday, not currently. Okay. So you have a certain redundancy built into your ability to understand natural language. So unless I really messed it up, it's probably still going to be okay. You can still understand what I'm talking about. When you're programming, that is not the case. Okay? Depending on the programming language, if you use a comma instead of a semicolon, the compiler will give you tons of error messages. If you use single quotes instead of double quotes, same thing. Okay, because they mean entirely different things. The worst part is the error message doesn't tell you what it is. Okay, the error message is always cryptic and it always points you to a wrong direction. So you will think that it's something else, but no, it's really just missing a semicolon. All right, so that's really the first obstacle, is to deal with the syntax of a programming language and also the errors, the not so helpful errors from the tools. Are there any questions about this part? And all computers are very strict about the grammar. You really have to follow the rules. There are programming languages like Python where an extra space at the beginning of a line can make the difference. Okay, if you have one space too many, it will change the behavior of the program. So you have to be careful with that. The second part or second challenge of becoming a developer is a developer has to deal with programming logic, or just logic in general. A systems analyst, when I use SA in this context, it is an abbreviation of a systems analyst. A systems analyst, which is the combination of an architect and the engineer, still has to deal with logic, but is a high-level logic. Typically, at that level, the logic can be specified by diagrams of some kind. Flow charts, stage diagrams. There are many, many different types of diagrams to express logic at that level. And for the most part, people can just look at the diagram and kind of, really understand, what the logic is about. So it's not really that difficult. When you become a developer, you have to deal with logic at a program level. This is a very low level compared to what a flowchart represents. In this case, we have to pay a lot of attention to the problem is details, okay? It is because you have to track a lot of details. You have to track the use of variables. You have to track, where, this particular line is in the context of an entire program, how it's going to be used by another, place. Yep.
Are you talking about like writing pseudocode or something?
It doesn't matter whether it's pseudocode or actual code. There's still a lot of logic. Pseudocode and actual code they're only different in the sense that the syntax is different, and pseudocode is intended for another person to understand the logic of a program, where an actual program, like written in Java or C++ or Perl, is intended for the computer to execute the instructions. But they still have the same level of details and the same level of logic. So this is why programmers or people who do programming require extended periods of highly focused attention to logic. Okay, you cannot really be doing much else when you're writing programs. You cannot be watching TV and writing programs. You cannot be chatting with another person and writing programs. Well, at least I cannot. Okay, some people may be able to, but I definitely cannot do that. And this is why a lot of times, even though a systems analyst really understand what the program or what the system is supposed to do, their various job requirements conflict with the characteristics of a developer. Because a systems analyst, which is an architect and an engineer, has to deal with the client a lot. Okay, they get calls from the client and say, oh, how is my system coming along? Or they have to respond to email and so on and so forth. So their days are filled with interruptions, meetings, and so on. And those events are not productive from the perspective of a developer. As a developer or a previous developer, I can tell you, I can just sit in my office and work for hours, 5 hours, 6 hours, without realizing the passage of time. If someone comes into my office and asks, Tech, I need da-da-da, I'll be interrupted and I'll be a little bit frustrated, when that happens more than twice. Okay, I do not like phone calls. I don't like meetings, when I'm writing code because it requires that much concentration. And when you lose the train of thought, it takes a long time to reestablish the context also. So when you're writing programs, you really need to be, kind of have your own space, and have a block of time allocated. And not everyone can stay focused for hours at a time. I was just talking about this in my morning class, and it is important to realize that this is not against people with ADHD or ADD in general. Attention deficit disorder, because you might think from the name of that disorder that people with that disorder cannot focus, cannot concentrate, and therefore they cannot write programs. Well, that's a misunderstanding of ADHD or ADD. ADHD or ADD simply means those people cannot focus when they're not doing something that they like. Okay? The flip side of ADD and ADHD is when they are actually doing something that they like, you cannot peel them away. they would just be glued, to do whatever they want to do or they like to do. How do I know? I think I have ADD. When I was a child, they don't really look for or diagnose that sort of thing. It's only when I became an adult, they go like, oh, so I have all of these signs when I was a child. I might have ADD, but they just call me lazy or bad student or, stupid.
That's true.
Go ahead.
Oh yeah, they diagnosed me with that ADHD thing when I was a kid. Then my dad just put me into sports and never talked about it again.
Well, for some people, it's really just a matter of time for the brain to develop. The brain just develops at a different pace. So, the frontal lobe, which is the quote-unquote manager, the supervisor of everything, some people have it developed really early on. So they can focus, you can tell them to do something and they can just follow the instruction. But for some people, it develops later. And therefore, as a child, those people cannot, do things that they are not interested in.
I'm definitely a part of that later group.
Which is okay. It just comes later and it's a different experience, for sure. Okay. The last part is the most challenging part, okay, debugging, which is also the application of logic, but this one is a little bit different, okay? When you're programming, you're constructing something. You're basically trying to figure out, okay, how do I express how to do something like this, okay? It's constructing something. This part, debugging, is deduction, okay? In other words, you already have a program that somebody wrote, and the program is not working the way it's supposed to. And you have to find out why it's not working the way it's supposed to and fix it. Okay, so this is, in my opinion, this is actually more difficult, but it's also more fun. Most programs do not work right the first time. Okay, my motto is, if a program works the first time, it's probably not worth the effort of doing it, because it's probably not, it's too simple to be actually useful. Software development is an iterative process. It involves these steps: thinking, constructing, coding, translating the logic steps into actual code, testing, making sure the code works the way it's supposed to. If not, go back to debugging and go back to thinking again. Okay, so it's basically a loop, and it takes a lot of effort to get it done, especially the debugging part. Diagnosing faulty programs can take up much of the work hours of a developer. Okay, so most of the time as a developer, you may or may not be actually writing new code. Okay, you may be spending a lot of time, 80% of your time, to diagnose problems of existing programs. In fact, I guarantee you, as the first job, as a developer or as a computer science graduate, you will be doing mostly debugging, because that's really the best way for companies to, one, test whether a particular employee has the aptitude to deal with programming, and two, for the new employee to get familiarized with the product. Okay? And people usually compare that to, cleaning a bathroom with a toothbrush. And not one of those motorized ones either. No sonic here. But on the other hand, it's really fun, because it's like detective stories. Okay, you have a symptom that can point in many different directions. So how do you test the program and say, oh, okay, I can rule out these possibilities, it has to be one of these possibilities, and continue with those possibilities? So to some people, it's like solving a puzzle, and it is fun. To other people, it is pure frustration. Okay, I know engineers who cannot deal with this particular step of engineering. They basically turn a mouse, such as this, into a bat. What is a bat? It's a flying rodent. Okay, so they just rip the mouse out of the computer and send it flying across the office. I know, because it happened in my workplace. Fortunately, I was not there when the mouse landed. But to some people, it is really frustrating. They cannot deal with the problem of, why is it not working? I tried all these different ways and it's still not working. Well, you cannot blame the program or the tools, because they don't respond to blaming or anger and stuff like that. They will keep doing the same thing over and over and over again if the developer does not change the way that he or she is doing things. Okay, and some people don't understand that part. They would just keep, okay, I'm going to run this command again. Wow, same result. Well, yes, it is going to be the same result, because it's a program. So this task requires a lot of focus, a lot of analytical, it demands a very analytical mind, and a temperament that stays calm after repeated failure to locate problems. Okay, and I think this part is really the most challenging part of becoming a developer or a software engineer. Okay, because the troubleshooting part can be frustrating to some people. All right, so are we still doing okay so far with this discussion? Okay. All right, so now we are moving on to a new topic. Let's talk about algorithms. The word algorithm can be defined, you can just look it up. I mean, you don't have to trust my definition, because you can just Google and say define, and then algorithm is the word that I'm trying to define here. So according to this, let me just unlock the font size here. An algorithm is a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer, which means it is not limited to a computer. It can also apply to people. You can give someone an algorithm and say, okay, follow these steps and perform these operations as specified. Okay, so algorithm is really just a sequence of steps in order to solve a problem. But in my definition, I kind of add a few more attributes to it. An algorithm is a method, but it also has some additional attributes. An algorithm has to be very precise. In other words, whatever language you use to specify an algorithm, you have to make sure that it's not ambiguous. In other words, it is not possible for a person to interpret an instruction one way, another person to interpret the same instruction in a different way. Okay? It has to be that precise. And it also has to be specific. In other words, an algorithm has to solve a particular problem. You have to know the behavior or the end result of the algorithm, really well in order for the steps to be called an algorithm. Okay. Are there any questions regarding these two attributes of an algorithm? Okay. Questions? Many of you are computer science, people, and you'll be moving on to a 4-year university, and then eventually you will be taking a class called algorithm analysis or the analysis of algorithms. It's one or the other. That class is very different from this class because in that class, it's basically a math class to prove the correctness of an algorithm or to figure out the efficiency of an algorithm. We'll do a little bit of that stuff in this class. I'll give you some exposure, but when you get onto those classes, they will give you a very formal treatment, of algorithms, and it's almost like a math class. It's not about programming whatsoever. Okay. Any questions about algorithms? Questions? Moving on to which talks about pseudocode. I don't use any actual code. We want to get hands-on experience with programming because we want to see something work. I will make a recommendation later. But as far as homework is concerned, your test exams are concerned, I'll be using only pseudocode, which means it is not intended for computers to execute. It's intended for another person to look at the code and say, okay, I know what this algorithm is. I can follow the steps. And pseudocode has certain advantages, definite advantages. You might think that for an entry-level class, maybe we should use diagrams, all sorts of diagrams like flowcharts, state diagrams, and so on. Because they are graphical representations, you have bubbles, you have lines, you have arrows, so it would be easy for someone to kind of follow the logic. That is true. But there's one big disadvantage to graphical representation of code is not concise. Okay, you need a lot of space to draw the picture to represent the same logic that can be represented by this much line, this many lines. Okay, so it's not very concise. This is the other disadvantage of a lot of graphical representations of algorithms. They do not promote structured programming. It's kind of hard for me to talk about what is and what is not structured programming because we haven't really gotten into the topics yet. But I can tell you one thing. If an algorithm is not structured, it can be almost impossible to actually implement. Even though you can draw that as a picture, it would be really difficult to turn it into actual code that a computer can execute. So we do want structured programming. We do want structured code, and flowchart in general encourages messy and unstructured code, and that's why I personally do not like it. I don't want to use it.
I have a question.
Check. Go ahead.
Yeah, I was speaking with some other instructors in the district,
Mm-hmm.
and there was like a little friendly debate in terms of how one should learn programming.
Okay.
And I found, and maybe you'll disagree with me, but I found that there are professors who, like this class, they have the pseudocode, and you don't learn nothing else. And then there's some professors that say, oh, there's no way you can learn to program with your pseudocode. You need to learn a language, and I know it's specific professor that advocates this.
Mhm.
So for a while, I didn't know how to take, whether I should take this class or to take a 301, which you
Okay.
actually learn the programming language. So,
Okay.
I'm trying to, and I'm listening to you speak. So what's your take on that in terms of?
So the comparison is between using an actual programming language versus using pseudocode.
Yes.
Okay.
And learning how to program. So because this one professor is like, they felt like it's ridiculous to even talk about learning program when you're not actually learning a language.
I would
Because
strongly disagree with that
Well, tell me
statement.
why. Tell me
Okay, I would strongly disagree with that. Let me just kind of echo, your
Okay.
comment to the whole class because they may not hear what you said.
Right.
So the comment was, whether it is better to use an actual programming language to teach programming, or whether it's better to use pseudocode to teach programming. And in this class, I use pseudocode. Well, if I use pseudocode and not an actual programming language, then what will be actually running the program? How do we test the program and find out what they do? Guess what? You. You'll be the biological organic computer running the programs that are written in pseudocode. Instead of having a computer to run the code that is written in a particular language. Now, why do I do this?
So how
Well,
do you-
one, it is painful. I like that. No, that's just kidding.
But I guess what I'm trying to say, the reason why I kind of lean toward 301,
Mm-hmm.
but it's because if you take the logic to its outcome, how can you do it without a programming language? Because it's all
But we
built on
do have a programming
it's all built on
language.
logic, right?
We do have a programming language. It's just not something that the computer can execute. So you will be the one actually, quote unquote, running the program because you have to be able to follow the programs line by line and know exactly what each line does, and then the next line, what does the next line do? And sometimes, where is the next line? It's not whatever is following it. It can be something, before this line. It can be something after this line. So you have to understand how each statement execute in this class, and not rely on the computer to actually run it and to get whatever result the computer is going to give you.
Okay, one more quick thing here. Okay, understand what you're saying. You say you have a programming problem. You
Mhm.
start with a problem, right?
Uh-huh.
Okay, so let's just say a person in your company or whatever, they don't know no programming language, but they're good
Okay.
at logic and they know your pseudocode.
Mm-hmm.
So under ideal situations, will that person be able to say, okay, I got this problem. And they make you this logic pseudocode, which according to their, outcome, it works.
Mhm.
And they give it to you and they say, okay, you find out what language you want to use to solve this problem.
Mm-hmm.
Is that a reality? Could that?
To implement the program.
Yes.
Yes.
Could that actually happen?
That can actually happen. Because once you understand the concept of programming and you understand the solution and you can specify the solution in pseudocode, turning it into C++, Java, Perl, Python, PHP, Lisp, Prolog, and so on and so forth, is a mechanical step. That step is really mechanical because all you're doing is you're translating the concept that you already have and express it in a different language. Okay, and that step to me is very mechanical. Yes, from time to time you might have forgotten the syntax of a language and get some syntax error. But syntax errors can be caught by a mechanical tool. The compiler or the interpreter can catch most, if not all of that. So the most important part of writing a program is not the programming language itself, but the logic of the program. And pseudocode can capture the logic of a program as well as, if not better than, most of the programming languages out there.
Yeah.
Okay, and this is recorded too, so if you want to present the argument to the other professor, you're more than welcome to use my YouTube video clip.
Gloves, huh?
Well, no, I don't put on gloves.
I'm just
I'm just presenting my view. Because from my experience, this is a usable approach. So let me go ahead.
We already have a programming language that we use on a day-to-day basis. We use English, although I think the challenge here is somehow using English in a way that's very non-ambiguous.
Well, pseudocode, even C, which is a very terse, programming language, even that borrows keywords from English. So when you're reading a C++ program or a Java program, because they are syntactically very similar to each other, you can still identify certain words in English. But the rest of the syntax is kind of cryptic if you're not used to reading a C++ or a Java program. So that really is a mechanical step, to me, the translation of the actual logic. And in this class, even though we use pseudocode, it's not really English-like. Okay, it has more words than C and C++, but it also has a very strange look to it, and we'll get to that, pretty soon. Yep.
Is all of the language require a language itself?
What is
Yes, it is. It's called a meta language. In other words,
What did you say?
to develop a language, it requires a language too. It's called a meta language because it's a language that specifies another language. In this class, we don't really talk about BNF or some of the other meta languages. I'll leave it up to the C++ professor to teach you guys the syntax of C++ because that's his job or her job. And besides, in this class, I don't want you guys to have to worry about syntax because that can be a very frustrating experience because you have two things going on at the same time. You have to deal with the logic of programming, and on top of that, you have to deal with the syntax of programming. And one can be distracting because when you're trying to focus on the logic and the compiler keeps giving you error messages, then you're distracted by the syntax. Whereas in pseudocode there's no syntax. I mean I don't really care whether you spell it with uppercase or lowercase. Simple stuff. As long as I can understand your program, it's still okay. Yep. Go ahead.
Does it matter whether you're using procedural or object-oriented languages?
Okay. Well,
the pseudocode.
The question is very good. Does it matter whether I'm using procedural or object-oriented programming languages or approaches? Procedural is the foundation of object-oriented programming languages. And in this class, we won't have enough time to get to object-oriented programming. We only have time to cover the procedural part. So, is that kind of answering your question?
I hear you.
Yep. Object-oriented programming is cisp300, and that's one step after cisp360, which is C++ programming. So that kind of gives you an idea of, the foundation is procedural, but on top of procedural programming, you can use the object-oriented way of looking at things, but the foundation is still procedural. Okay, it is still based on conditional statements, loops, and so on and so forth. It has to do with how do you organize the data structure of a complicated program. All right. I like all of those questions. I think they all reflect a lot of thinking on your part, and it's really good. Are there any other questions that I can answer, or any other comment that you want to express? Other than it's kind of stuffy and hot in here.
Did you go to logic again? Did you go to the part where in logic again?
The logic?
In terms of how we're defining logic in this class.
Well, let me give you a sample instead. Okay, so what I can do is I'm going to, kind of just move ahead of time, and let's take a look at some somewhat complicated logic. And we're going to take one. These are the ways. So this is really way ahead of time. This will be typically halfway through the semester we'll be talking about this. But I just want to give you an idea of an algorithm. It doesn't look well, it doesn't look right because the indentation is lost here. But that's basically what the program looks like in pseudocode. You can still see words that are expressed in English, but at the same time it also has symbols intermixed, that is kind of awkward from this perspective because
Like
we haven't.
algebra.
It has a lot to do with math. Yes, it has a lot to do with math. So I just want to give you guys an exposure just so that you know what programs will look like in this class. All right, so getting back to pseudocode here. I'm not going to go through these sections here because one, I'm not going to ask you any questions related to this, but more importantly, I think it's kind of hard to talk about this before we actually look at some code. So we'll just kind of not talk about this part because I actually talked about a lot of that already in this, in this particular class session. So we'll just kind of skip this and go back to the main site here, and we are moving on to topic 2. I'm going to turn the highlight onto topic 2 so that you guys know where we are in the class. So when you're reading these notes here, you know where you should be at this point. All right. Oh, that's not the one. Oh, I clicked the wrong button. I hit it instead. Should be highlighting it. There we go. All right. So we are now on topic 2, and I'm going to go through these topics, in this particular order. So we'll start with variables, expressions, and sequences. They are they're the simplest constructs in programs. So we leave this one here. All right, so we'll talk about an example first. Okay, the example is something that people do not do anymore. It's called balancing your checkbook. What is balancing my checkbook? I have the Wells Fargo app. All right, so this is what people used to do, back 30 years ago. I'm exaggerating a little bit. So when you get a credit card bill through your mail, which some people do not get either anymore, you would just read your credit card bill, and let's just say that you can pay off that credit card bill that month, okay? And we'll just make the assumption that the balance is X dollars. Now, right away, why do I use X to represent the actual balance of this particular bill? Say again? Yeah. Can be any number. It changes from month to month, right? Okay. So I cannot just use a particular number, as the balance because we don't know what it is. Okay. Very good. So that's one concept you have to kind of grasp already is, hey, we don't know what it is, but we know it is a particular number. The next step is we're going to write a check of X dollars to the credit card company. Wow. Do you think the X of the second line has anything to do with the X of the first line?
Yes.
That's exactly why we use the name, a particular name. It doesn't have to be X. I could have called it Y, or I can choose any name. But whatever name I chose on the first line, I should keep it to use the same name throughout because I'm referring to the same amount. Okay. Are there any lawyers or legal aid in this class? No. Okay. Yeah.
Now, the
Okay.
X on the first and the second, this would only be accurate if they're actually paying off the whole balance.
That is correct.
If you're
Yeah,
not paying off, then you have to use a different order.
Then you the overdraft in the checking account. Yes. So I'm making the assumption that they're paying off the entire balance of a credit card, which is a good approach anyway. If you leave any type of balance, the interest would just it would just eat you alive.
Yeah.
Yep. Okay, so we're assuming that we're paying the entire balance off. So this X and this X here, they are actually referring to the same amount. Okay, so that is something that is important. And then as a result, you want to deduct X from your tracking of how much money is left in your checking account. I just called it available funds. But in the good old days when people cannot do online banking, they have to manually keep track of how much money is left in a checking account. So every time you write a check, every time you withdraw money, you have to make sure that you're balancing the checkbook. And then if that person also wants to keep track of how much money is spent through a particular credit card, you can now you can add the amount of X to the total amount or total expense for a particular credit card. It may be a gas card, so you can track how much money you spend for gasoline, or you use a credit card for a particular purpose, and it is meaningful to keep track of how much money you spend through that credit card. So does everybody understand what these 4 steps are representing in terms of actual things that people do? Okay. All right? So what we'll do next is to introduce the concept of a variable. A variable, as the name implies, is an object, something, that can hold a value. But the value can change over time, and therefore the name is a variable. Formally, a variable has three attributes. The first one is name. X is the name of a variable. Okay, it's an identifier. It helps us to distinguish a variable from all the other variables. Okay? In a program, in a particular context, the name should be unique. In other words, when I say variable X, only one should exist. Okay? There should not be any ambiguity of, oh, which variable X are we talking about?
Shouldn't it be the data type?
X is the data type.
No, I'm saying shouldn't the data type come first?
Doesn't matter. These three are all attributes of a variable. So every variable must have these things. So the name is important. I'm not going to skip type for the time being. I'll just skip to value, or the state of a variable. So a variable has a state, a value, or quote unquote content. If you look at a variable as a coffee mug, okay, the content inside the coffee mug is the value. And that can change. In other words, you can have the same variable, a coffee mug. Sometimes it's empty, there's nothing in it. Other times it is full, and other times it is only half full. Okay? And that's why a variable is useful, because during the execution of a program, you can pour the content of one cup into another cup, you can empty out the content into the sink, and so on and so forth. Okay? So the content or the level of content can change over time. Type is a somewhat more advanced concept, because what it does is it limits what kind of value a variable can contain. Okay? If you like the coffee mug analogy, it means with a coffee mug, you should only use coffee. It should only contain coffee. With a wine glass, it should only contain wine. A beer mug should only contain beer. Okay, so that's kind of the meaning of a type here. We will go back to the meaning of a type of a variable later on. So for the time being, we're only dealing with numbers, so we're not going to talk too much about the type of a variable. All right. So given that we now know these things about variables, how many variables do we have at this point from the previous example? Well, this one is obvious. X is a very obvious example, because the value does change because it depends on the amount on your bill. Okay, so this month it may be $200. Next month it may be $150, and so on. It will change over time. And the name is X itself. The type I'll just call it money. But it's really a number. The other variables that are already here, but it is not as obvious. One is available funds. Okay, because how much money you have left in your checking account is not constant. When someone cashes your check, the available funds will drop. When you deposit your paycheck, the available funds will increase. So that really is a variable as well, even though the name is not awkward like X. Okay, but it really is a variable. It changes over time. And in this particular example, I'm just going to say available funds is the name of that variable. We have one more variable. In this case, I'm just going to use American Express as the credit card. So this would be AE total expense. It should have been AE annual total expense, because it is going to be reset every year at the beginning of a year. But we'll just call that AE total expense. It is also a variable, because it gets reset to 0 at the beginning of a year, and then each month you will add new amounts to it, so it will increase over time, over a year. Are we doing okay so far, identifying the three variables in the example that we just talked about? Is that okay? All right. So the next slide talks about expressions and assignment statements. Expression is easy. So I'm going to start with slide 4.1 here. about assignment. It's going to talk about, no, I guess we don't have anything that talks about expressions. At this point, when we talk about expressions, it's really just arithmetic expressions, okay? Plus, minus, addition, subtraction, multiplication, and division. The only thing that I want to make sure everybody understands in this class is the priority of multiplication is higher than the priority of addition, okay? Which means this. I'm just going to use Notepad, as my whiteboard, because this way I can capture it with my screen capture. So let's change the font to something bigger so you can see. That'll work. Okay, so when it's the distributive, take it back. It's just the priority. When I give you an expression like this, A times B plus C, it really is the same as A times B performed first and then plus C.
Mm-hmm.
In programming or on a regular keyboard, we don't have the multiplication symbol. And so it's very typical for a programming language to use the asterisk symbol to represent multiplication. So in this class, we definitely use that particular convention. The asterisk symbol means multiplication. So I just want to make this clear because throughout this class we'll have expressions, simple expressions like that. I just want to make sure that people understand that if I don't specify the parentheses, it is the same because it is understood that multiplication should be performed first. All right. So the first part is about assignment statements. So we'll just go ahead and take a look at assignment statements first. In general, every assignment statement looks like this. It has a LHS, which stands for left-hand side, and RHS stands for right-hand side. Okay, it's kind of obvious, right? And in this class, in pseudocode, I use a left arrow in between. So the left arrow is separating the left-hand side from the right-hand side. The left-hand side specifies which variable you want to update. So let me just kind of point out which part I'm reading here. The left-hand side specifies what is getting updated, which variable is getting updated. The right-hand side, on the other hand, specifies the value or the new value of whatever you are updating. The symbol, which is a left arrow, indicates the direction of information flow, which also tells you that you have to evaluate the right-hand side first, because until you evaluate the right-hand side, you do not know the new value that you want to put into the left-hand side. Is that okay so far? Okay. You can also see that LHS and RHS are in italic, and this is actually getting back to the meta language thing, a language that specifies language. When something is in italic, it means it is a placeholder. It should be replaced by something else in order for it to be useful. Okay, I'm not going to get too much into the meta language thing, but I just want to point it out whenever it is convenient. Yep, go ahead.
When you get into types, will you be explaining which flow they go as well? Like, you get what I'm saying?
No.
Like for instance, you talk about like the Boolean versus just doing a different.
The type does not change the flow. It's always from the right-hand side to the left-hand side. Yeah, it's always like that with an assignment statement. This is a good time to also cover this part here. The symbol that I use, which is a left arrow, is not typically used in an actual programming language. In an actual programming language, in almost all of the programming languages out there, the left arrow is replaced by a simple equal symbol. And to me, that is very misleading. Okay, it's extremely, extremely misleading. Let me give you an example to illustrate my point. Okay, if I say x left arrow 5, I know we just got into this topic, but just based on what I talked about, the left-hand side is the variable to be updated. The right-hand side is the value that you use to update the left-hand side. What do you think will be the effect of this particular assignment statement? X will have a value of 5. Okay, after this statement, x has a value of 5. X is a variable. Okay? And this has a very different meaning compared to x equals 5. Okay? Because when you typically see x equals 5 in a math class, what is it saying? It's stating a fact, right? It is not stating an operation, it is stating a fact that x equals 5. Or worse yet, it is asking a question. Does x equal to 5? Is it true or is it false that x equals 5? Okay? So that means, when we use the equal symbol in programming to mean assignment, it really has a completely different meaning when we use compared to the meaning of an equal symbol in a math class. It is entirely different. And the next example should illustrate what I mean by that. X gets x plus 5, x plus 1, as opposed to x equals x plus 1. Okay, let's take a look at this one first. This is a program step. Okay, the right-hand side is expressing the new value. The left-hand side tells us what we are updating. So what do you think is the effect of this particular statement? What are we doing to x?
You're adding 1 to it.
We're adding 1 to
You're
x.
increasing it.
We're bumping it up by 1. Okay, so we are bumping up the value of x by 1. If before this statement x had a value of 20, then it becomes 21. Okay, is that making any connections? Okay, because it's a two-step process. One, evaluate the right-hand side using the current value of x. Step 2, update whatever is on the left-hand side to the value. So there's no problem of using x on both sides in this case.
So if you can do it that way, why not do it left to right like we read mostly? So have the updated value x plus 1 going into
That is a good
x.
question as well. I do not know the answer of that. I think it has to do with the confusion of statements in mathematics, because when you state x has a value of y plus z divided by 2, you put x plus z divided by 2 on the right hand side by convention. Okay, so it's really a convention.
It could be that what you just said. It says this is what x is. X is x plus 1. As opposed to it being one or the other. That is a statement of fact in mathematics when you have it on
Exactly.
the right hand side.
So now let's take a look at the highlighted portion now. Okay.
Yeah.
If you ask a math professor what is x equals to x plus 1, what would be the answer from the math professor?
That's incorrect. There's no solution.
Well, there's no
It's
solution.
undefined or indeterminate.
No, it is false. It is a false expression. Because x equals x plus 1 is a question. Okay, is it true or is it false that x equals x plus 1? Now, because there cannot exist a value such that that value is equals to itself plus 1, so that means this expression has to be false for all possible values. It doesn't matter whether you're dealing with real numbers, natural numbers, rational numbers, irrational numbers, and so on. It cannot be true. So a math professor would just say, oh, it's false. Okay, it cannot be. Because it's not specifying an operation in mathematics, but in programming, in C, C++, Visual Basic, and all basically known programming languages, they use this notation to actually mean this. So you have to keep that in mind, okay? Really, really keep that in mind. Oh, but then in programming, how do we actually evaluate whether x equals to 5 or not? Because if a single equal symbol means an operation to update the left-hand side, what do we do when we actually want to say, well, does x has a value of 5? What do we do? Well, that depends on the programming language. In Visual Basic, you can express this in the context where a true false value is expected. Then it becomes a comparison. In C and C++, which most of you are concerned about, it is expressed this way. A double equal operator is a comparison. A single equal operator means assignment, means changing, updating the left-hand side. So you have to drill that in your head, because someone, or more than one person in this class, will get bitten by this one, using a single equal instead of a double equal. And the program is syntactically correct, but it will perform the wrong operation. Okay? And those things are really hard to catch too. I know because I have stepped on this landmine multiple times. Yes. All right. So this is a single assignment operation, and then the next slide talks about a constant assignment, which means the right-hand side is just a constant, pretty easy to deal with. Okay, whatever the constant is, we update the left-hand side to that constant, and that's the end of it. Okay. But what happened to the value, whatever value that AE total express had before this operation? What do you think? It's gone. Okay? It's gone. A variable can only contain a single value. So when you overwrite it with an assignment statement, the old value is gone. There's no way to retrieve it. Okay? So you got to keep that in mind as well. This one is, what we just talked about a little bit earlier. We have the same variable appearing on the left-hand side as well as the right-hand side. So it looks really confusing because, what do we do? Because we are updating the very same thing that we need to use in order to get the value to update the other side. It seems cyclic, but it's not. It is not cyclic because it is always a two-step process. Evaluate the right-hand side, then update the left-hand side. And then you're done. You move on after that. Okay? So in this case, all we are doing is to update the value of total expense, AE total expense, and bump it up by the amount of X. That is all that we are doing. All right? And there's an example in the text here. Do we have any questions about assignment statements? Any questions about assignment statements? So let's go ahead and move on to tracing or visualizing operations involving assignment statements and variables. This is a really crude way of doing it, because I usually use a spreadsheet for this purpose. Okay, so the way we do it is the way I trace a program is to use a table. In this table, let me just kind of read it in a certain way. When you read the table horizontally, it is a slice of time. When you read the table vertically, it is the historical record of a variable. In other words, when you read it down like this, it is the progression of time. When you read it across, it is stating the current state of all the different variables at a particular time. Okay, so it's a time slice horizontal and historical record vertical. So this is a good time to show you what I typically would do when I trace an algorithm. Eventually we'll be using Linux on this computer, but for now I'm just going to use Windows, and we still have LibreOffice, which is good. I cannot use Microsoft Office because I just have not used it. Yep.
You always have to have an assignment to your variables, or is that optional?
Say again?
Is that optional to have an assignment to your variables? In other words, set the time you have to have it. Or can that be optional?
An assignment statement is the only thing that can update or change the value of a variable.
So it's not like an instantiation or anything like that?
Instantiation?
Yeah.
No, we don't have any constructor in the object-oriented program. Okay. All right. Sorry? All right. So what we will do is I'm going to write the code here, and then I'll trace it. It's very typical that I use this particular format to do it. When I express an algorithm, I would use column D to actually express the algorithm. And in this case, let's go ahead and start with first thing is to turn off certain things here. And I think it's under it's under autocorrect. You probably have to do the same thing when you work on the homework assignment. I'm turning off some options here. This replacement table do not make other types of corrections. There we go. Okay. So now I'm going to express a certain algorithm here. We'll start with k gets a value of 20, y gets k plus 2, And then k itself gets k plus k divided by 2. Okay, so this is my program. And I will use column A to number the lines. I know the row number is actually the same as the line number, but I'm going to use another column just to indicate the line numbers. So 1, 2, and 3 in column A are the line numbers, and then column B is representing the actual statements on those particular lines. This is how I would write an algorithm in this class. Next, I'm going to trace the algorithm. When I trace an algorithm, I can use these cells here, but I typically would use a new sheet to do it. So I would use a new sheet inside the spreadsheet document, and then I would use a new window to trace the execution of this program, and so I can display the algorithm along with the trace. When the program is small, it doesn't seem to make any sense because it looks like I'm doing a lot of stuff that is unnecessary. When we progress in this class, the algorithms will get increasingly difficult and complex. So a lot of times, even though the program or the code itself is only about this short, the trace will get long. And that's why it is helpful to learn how to use a different window to display a different sheet for trace purposes. Okay, so we're going to get started here. One column will be used to indicate the line number. And then for each variable in this program, I'm going to use one column to remember the history of the value of that particular variable. So these are the heading of the 3 columns. Line number to indicate which line we are talking about on each row. And then k has a column for its values, and y has a column for its value. We start with a precondition. Okay? So every program starts with a pre. The pre is basically saying, can we or should we use any assumptions about the value, the initial value of k and y? Okay? In some cases, I might give you some precondition and assumption and say, oh, you can assume that k has a value of 20 to start with. Or you can assume k has a value of -20 to start with. In other cases, such as this one, I can tell you, don't make any assumptions. K can be anything, y can be anything when the program starts. So in this case, I use a question mark to mean that I don't know the value of k, and I don't know the value of y either, before the first line executes. Are we doing okay so far? So you're grabbing a coffee mug out of somewhere, and you don't know whether something is already in the coffee mug or not. That's the assumption. All right. So we move on to line 1 after the precondition. We move on to line 1. On each row, we are writing down the values of each variable after that line executes. So what do you think I should put here in the cell that is currently highlighted? 20. Very good. Because this operation is an assignment operation. It evaluates the right-hand side, which is a constant of 20, and then it updates the left-hand side, which is our variable k. So after line 1 executes, I know for sure that variable k should now be updated to a value of 20. What about y? It is still a question mark because we haven't done anything to y yet. So if it was unknown before, it is still unknown after line 1 executes. Are we doing okay so far with this convention? It's a convention. Now, let me just finish the entire program and then we'll come back and look at it again. Okay, here's line 2. I'm indicating that I'm trying to express the values of variables after line 2 executes. What do you think would be the value of k after line 2 executes?
20.
Go ahead. 20. Okay? It will still be 20 because we haven't done anything to k. Which variable is affected by line 2? Y. Because y is the only one on the left-hand side. Okay? Even though k appears on that line, it is on the right-hand side, which means it's only supplying a value to evaluate the right-hand side. So k doesn't get any change, so it will keep its own value of 20. What about y? What would be the new value of y in this case? It will be 22 because k has a value of 20. You add 2 to it, it becomes 22, and then we use that value to update y because y is on the left-hand side. So y now has a value of 22. And we're moving on to the last line of this simple program. What do you think would be the value of k after line 3 executes? It'll be 10, right? Because it had a value of 20 before. 20 divided by 2 is 10. And then we use the value of 10 to update the left-hand side, and therefore k gets a new value of 10. Is that okay?
Wait, I was gonna say you're missing y.
Hmm?
I was gonna say you're missing the y. You didn't put it in line 3 yet.
Well, let's see
The
here.
y is
What would be the value of y?
22.
It will still be 22 because line 3 doesn't do anything to y. If y had the value of 22 before, it will still have a value of 22. Now you have the end of the trace. At the end of a trace, I always do this. I always just write down post here for post condition. The post condition is representing, okay, this is final. Okay, these are the values, the final values of the variables after the entire program executes. Okay. It's just a little convention, but I think it is useful. It's just like QED in a math proof, to indicate that's the end of the entire process. All right, so you have a trace here, and going back, if you just look at a single row, like the line that I have highlighted here, this is a slice of time in the execution of this program. It is telling me that at that particular moment, after line 2 executes, k ended up with a value of 20, and y ended up with a value of 22. That's what it's talking about. When you look at a column like this, it is telling you that the value of k started off being unknown. It got changed to 20, it kept at 20, and then it got changed to 10, as the last step. Okay? So vertical means, the history of a particular variable. Horizontal is a slice of time. All right. So I think that also helped to answer your question because we are using pseudocode. So what are we going to do about the pseudocode? We run the pseudocode manually. That is what we're going to do for the entire semester. For some people, it is excruciating painful because it can get very tedious. For other people, it is helpful because until we know what each line is going to do, you should not let the computer decide what it's going to do. Okay, so that is the reason why I use pseudocode, to make sure you guys cannot run it through a program to figure out what a program is doing.
Okay, so but you use this what's that, Excel kind of
It's a spreadsheet. I just use it as a huge table basically.
Yeah. So what other type of outside of using a spreadsheet, what other type of, I don't know what word of a better word, a framework?
Document.
Yeah, could you run that another way without using, is there?
You can do it on a piece of paper. I'm just using a spreadsheet because it's already lined, it's already in a table format. It's just a whole lot easier for us to visualize.
Okay.
But that's also how your homework will be done. So you guys will also have to use a spreadsheet to do your homework because you'll be doing pretty much the same thing as what I do in the class. All right, so this is how we trace a program. And let's get back to the notes here. And I'm done with this particular section. We still have 8 minutes, so we are not quite ready to go yet. Okay. As much as we want to go home and have dinner, sushi comes to mind, so I have to. It's the ADHD kicking in. It's like, oh, okay, I want sushi. I want my raw fish.
I'm going with you then. That sounds good. Sushi. Yeah.
I like uni. Sea urchin.
Tempura.
Hmm?
Is the tempura with it?
Yeah, sea urchin. Uni. All right. So at this point, we can write programs already. We can write programs that only involve assignment statements, and it can only go in a straight line. Okay? But nonetheless, those are algorithms. You can express different steps of doing something, and you can step by step, come up with the calculation of a particular value. So it's not entirely useless, but it cannot express, really useful programs either. What this section is going to introduce are the concept of conditions and conditional statements. Okay? Now, if you just kind of jump ahead of me a little bit, you will see that I do use graphical representation of logic, but only at the very beginning of this class. So if you go, I cannot remember where I put that diagram. I would say it's about here. Yep. So we do have pictures and diagrams,
Okay.
But this is what a conditional statement is. A conditional statement is also called a branch. Okay. So imagine you are looking at a map of a trail, a hiking trail. Okay. And at a fork, you have two ways to proceed. Okay, and that's a conditional statement. There's only one you can only choose to go down one of the paths. So how do you decide which way to go? Well, fortunately, in programming, whenever you have a branch, there's always a sign next to the branch. And the sign is always going to give you a question, and the answer can only be true or false, such as x is less than y. Well, is it true or is it is it true or is it false that x is less than y at that moment? Okay, so you can always come up with an answer, but the answer can only be true or false. Now, once you have the answer, it's easy because one path is labeled true and the other path is always labeled false. So you just follow the path of the right label, and then you can perform whatever operation is specified on this side, the then side or the true side of the branch, or the false side of the branch. But then the two paths will merge at the end of a conditional statement. All right, so it's called a conditional statement. It's also called a branch. It is a mechanism where your program can make a choice, left or right. Yep.
If then,
What would a conditional statement look like on the table?
On the table? Well, that's a good question. We have 4 minutes. We might be able to get to it. Go ahead.
now I'm just looking at if then else statement. That's all I'm just looking at. If then. Go ahead.
All right. So you guys are curious of how do we express this? I'm going to give you guys a more complete treatment, next Tuesday, on this topic. But I do want to kind of give you guys a kind of a really quick peek of how do we express the execution of something like this, because it can go either way. So let's go ahead and make a new spreadsheet and express the algorithm. So this time I'm going to do something relatively simple. X starts with a value of 3. So I will say if x is greater than 4, then we do this operation here. Okay, let's say x gets x plus 1, else x gets x minus 1, and if. This is the pseudocode corresponding to the picture. Okay, so what it means is this is the statement outside of the conditional statement. So line 1 is outside of the conditional statement. The conditional statement goes from line 2 to line 6. This is the sign. This is the sign next to the junction, next to the branch. This is corresponding to what you have to do when the expression is true, and this is expressing what you have to do when the condition is false. Okay. When we trace something like this is what we do. This is going to be the last thing that we do because we only got 2 minutes and a half. All right, so we'll trace this program. We have line number. We only have one variable in this case, which is x. The precondition is I don't need to know anything about x because I'm going to overwrite its value on the very first line. So I don't really need to know its previous value. After line 1, x gets updated to a value of 1. And here's the funny part. On line 2, I actually need a new column. I just call this column comments. But what I'm going to do with this one is I will say x is greater than 4 is it true or is it false? It's false. Okay? So we use the comments line to say that it is false because if you just look at the value of x, it's 3 because it's not changing it. But I do want to indicate the result of the condition. X is greater than 4 is false. So where should I go next?
For the true side.
We have to go to line. Well, I only use line 5 because line 4 doesn't really do anything. Line 4 is what I call a marker. It's just a separator to separate two parts of the same statement. There's nothing to do on line 4. So when in a trace, I only trace line 5 because line 5 actually does something. What does line 5 do to x? It decrements it by 1. So it was 3 before, now it becomes 2, and then we are done. We get the post. I do not indicate the execution of line 6 for the same reason, because line 6 doesn't do anything. It is just an indicator that that's the end of a conditional statement. Now, I know I'm kind of flying a little fast here because I'm skipping a few steps, explaining the correspondence between the pseudocode and the picture. So you guys might want to read the whole conditional statement document, and then on next Tuesday when we come back, then we'll actually start to explain it, from the beginning again. All right. So don't forget, if you're on waitlist or not even on waitlist and you want to participate in the Moodle activities, write me an email and tell me your first name, last name, and student ID number, so that way I can add you into Moodle.
Right now, I'm signed on the room above right here, and you marked me as absent and I dropped from your class.
Oh, so you bought the wrong place?
Yeah, this is I put my name, this is my actual name, and I put it on the name above. And if I come out, I'm going to tell my dad I'm not in this class anymore.
That's okay.
He will kill me.
No, he's not going to kill you, but I can add you back. So you are... You're me. Okay, so...
I was here yesterday.
Oh yeah, go ahead.
She just went over everything I read.
I was looking at Moodle last night and I couldn't find.
Because you went off.
Yeah.
That's because you were dropped. So that means... well, you can watch the whole video.
No.
Okay, so I'm going to give you a permission number just so you can add that to the class. You can just use a permission number. The permission number is specific to the class. So if you just use a permission number to add to the class, yeah. No. No. I think they'll give you a refund, but since you'll be using that refund immediately for the class, don't think you have to pay again. Yeah. So go ahead and write down your permission number here. That's your permission number.
Can I sign in?
Yeah, you can sign in.
Okay. Is it this sheet right here?
Yep.
Today's?
that
Okay.
one.
Thank you.
Okay. All right. Well, do it right away so that Google will add you tomorrow in the morning.
Thank you. So how many open slots do you have as of right now?
As of right now,
Yeah.
I do not know because I cannot drop anyone because of one absence.
Okay.
Next Tuesday would be the day that
Next
I can drop
Tuesday.
somebody.
Okay.
So the way it looks right now, we have 1, 2, 3, 4. But these people were missing already. So we only have 2 people who, 3. Yeah, we only got 3 people who started to miss the class. Oh, I forgot about this guy here. So maybe 3 spots or so. So I'm going to move down the wait list and figure out who I can send a permission number to add to the class.
And the last day to add classes is September 8th, right?
Well,
Or September 9th?
technically that is true
Uh-huh.
if you are only using a permission number and my signature. If you can get a dean to sign a petition form,
Yeah.
then it can extend a little bit beyond that.
Okay.
But then it still depends on when the dean is willing to sign more petition forms. So I do not know. You can ask him instead of me to find out,
Okay.
approximately when he will actually draw that line and say, okay, we cannot add any more students. But the most important part is you have to keep coming to the class, because if you do not keep coming to the class, then I cannot agree to the petition because you will be missing material.
Right.
You cannot just start from like week 3. So
Okay. So I'll just keep coming then and see what happens.
exactly, unless you have another class at this time that is likely that you can get into,
Yeah.
then by all means, go to the other class. But if you have no other options at this point, you can just keep coming here.
Okay.
Yep.
Thank you.
There's also a CISP class on Monday, Wednesday at 5:30. That's pretty
AM
good.
class this morning.
Okay.
I sent
that
an email on your
what
page
campus
saying
is that
it's
here?
down,
Right here?
but
Yeah.
I find out that
No, I mean,
it's
not
in
the
the
same room,
conference
it's over
schedule,
there
so
somewhere.
I'm
Right,
trying to be
right.
added to this class.
Concrete, huh?
So
Send me another
Yeah, I
email.
did.
Okay, so
The
I'll
guys-
process
the guys
that.
explain that in the email.
Okay, all right, that's good. Thank you. Thank you for talking to me in person.
Thank you.
Yes, go ahead.
So I noticed I wasn't added in the middle yet. If you're on the wait list, are you not added?
No, if you're on wait list, it's not automatic that you get added to Moodle. So I will have to actually do that. And besides, not everybody on wait list is still coming. So I'm not just going to blanket it and add all the people on wait list to the class. So send me an email. Let me know that you want to be added to Moodle. You probably are on Moodle already. I just need to enroll you into the class because you
Yeah.
took a class from me
I was
already.
able to sign in everything. I just didn't have your class added. I was able to sign in. I just didn't have any classes. So
Oh, okay.
yeah. So I just guess I have to send you so you can get me enrolled.
Okay. Are you on wait list?
Yeah, I think I'm number 15, but with all the people missing from the wait list, it bumped up.
Yeah, that's the nice thing, because by the time we get to next, Tuesday, that list will get even shrink. It will shrink even further. But people who are already in the class, very few of those would actually drop the class. I was actually surprised that 4 people, do not show up here, because they basically, if they don't show up today, it's very likely they won't show up next Tuesday.
Yeah.
Because this is still the beginning of the semester. So I think, there'll be spots opening up. If you're on wait list, you stand a pretty good chance to be able to add to the class before the dean says no.
Yeah. I'm definitely gonna wait it out.
Yep. Well, if that is the only thing you can do, that's the only thing you can do at this point. Yep. Yep. And this is already an extra class.
Yeah, right.
This class got added, pretty late in the game because they found out that 3 of my other classes got low enrollment, so I could not teach that class. So they canceled that class and opened up this class, so I have something to teach.
It's too bad for the others.
The other 3, yeah, but it was low enrolled, and there's no way we could keep that class.
Could I see the list real quick, or just see like on wait list how I stand so far?
Okay.
Yeah, I just wanted to say I'm sorry I came in late. I'm trying to add 2 classes. One of
That's
them's
okay.
a little bit before, and it's at CRC, so.
Oh, that would be a pretty much as far
It's
as
a
you can go.
commute, yeah.
That's as far as you can go amongst
know.
the campuses in Los Rios.
Yeah, it really, well, Folsom, I guess, would be a little bit further, wouldn't it?
Folsom, if you go on Madison, it's not that far.
No?
You don't have to go back onto Highway 50. You can actually go on Madison.
Oh,
or
really?
Back or one of the other. I cannot remember which one. But
Yeah,
you
I
just
think
go
you're right.
across
You're
and
right.
you can skip the highway altogether.
That's a good point, yeah.
But
So anyway.
Yeah, so that's okay as long as you remember to initial your name here.
Yeah,
You're on wait
definitely.
list?
No.
Oh, you're not even on wait list.
I'm not even on the wait list. I'm just,
Well, we'll see.
I'm
We'll
just
see what
thinking
happens.
that,
A lot of people who came Tuesday didn't come on Thursday.
Yeah.
yeah, it looks like there were
Maybe
10
they look
people
up.
on the,
Maybe some people decide to look up, ratemyprofessors.com and look at my comments left by my other students. Go like, oh no, I'm gonna drop the class now. Yeah. Well,
it's hard to imagine.
So I'm just gonna X out these so that people cannot come in next time and backfill the name.
Oh, go back and, yeah, that's a really good idea.
Alrighty.
Have a good weekend.
You too. Don't forget to send me an email so you can actually read the material because we are actually getting
Oh.
into. Yeah. Oh, you came late. Okay, this is
I
my
didn't
email
realize that
address.
if we weren't on.
I can add you into this system.
Okay.
So you can have access to the homework
That
assignment
would be
and also the
great.
reading material, but you won't be officially in the class until I actually add you.
Sure, but as long as, accessing the material, that would
Yep.
be great.
Yep.
I was madly trying to take notes
I
tonight.
remember you and me and you were both skinny.
Huh?
I remember you and me and you were both skinny.
Oh.
I just want to find out, because I don't want to waste my time or anybody else. The only way I can get in this class is with the permission of it. How many people are in front of me?
Well, that depends on who you are, where are you on the list.
This me right here.
Okay, good news is, there's a whole bunch of people stop showing up on waitlist. So I have already added people up to here.
Okay.
So even though it looks like it's quite a bit down there, you really only have maybe 5 people,
Okay.
ahead of you. So it's not too bad.
Okay, so I'll send you the stuff for I can sort of for the Moodle stuff.
Yeah.
Okay. So I'll see you Tuesday then.
All right.
All right, take care.
All right, so
She's in line first.
just send you this information just like that, or?
Yeah, just send me your
Okay.
first name, last name, and student ID, so I can, if you're not in the system already, I can add you to the system.
I won't be in the system, I've never.
You have not
I've
used
never
Moodle
done
before?
Moodle, no.
Okay.
No,
So
Tuesday
that's
was the
what I
first I'd
need.
ever heard of it, so.
Oh, okay.
Okay, I'll do that, thank you very much.
You're welcome.
Hi, how are you doing? I'm Denicio.
Okay.
I showed up for class today. It said it was open. It said still on the
I
class
don't know
search,
when
but,
they close a class.
Yeah.
That's not something that I can do. There's no button that I can click to
that
close
says
the class.
closed.
Yeah, but you can tell from the wait list. I have a wait list up to this long, and then this many people on top of the wait list.
Okay.
So
Is there any chance that I could still write that on there and just just hope that I can get in and stuff?
Well,
like
you
it's
can
gonna show
hope,
up?
but I'm not
Yeah,
sure
well,
your chances.
Yeah, well, I'm gonna crash other ones too. I'm not just gonna do this one.
Okay. Well,
Yeah.
if you want to,
just in case.
just add your name at the
there's
end.
there's a few other cis300 classes.
Yeah,
There's ones at like 10:30 in the morning, like every day of the week.
Are you in this one already? No. Which So
Okay,
you said you're gonna do the
well.
one on Monday?
You can write your
I don't know
name.
yet. I don't know what I'm gonna do.
So you're in the same boat as him?
Are you talking to him, right?
Yeah. No. You,
Yeah.
okay. So, any question I can answer?
I'd like to add the class because this is one of those core classes that's required. My counselor said, go do this and then you can graduate. So here I am.
Yep.
Yeah. And
I understand.
I would like to be on Tuesday, Thursday because I'll save gas by showing up only 2 days out of the week instead of just all 4.
Mm-hmm. Do you know where you are on the list?
I wrote my name down.
Oh, you're post wait list.
Are you gonna
Okay.
write your name on there?
Well, I don't know. I mean, it depends on whether people start to drop off, from the class. So I can't really make any guarantees. I can talk to the
Could you
dean.
make the next class session like really scary?
Yeah, it's
Yeah.
weird.
Well, it's not quite Halloween yet.
Okay.
Do you have other sections at other times that you might have more
They're all
seats available?
full.
No. Okay.
Yeah, they're all full. Well, you're not here on Monday, the other day, so
Oh,
you
yeah, I
cannot
just
claim that you are here.
Should I have written my
that
student ID
was
down?
me right there.
Does it matter if I
This
have my
one's
student
me.
ID on this list?
That was
Or not?
that Dante guy.
Oh, that's Dante. Oh, never
no.
mind. Sorry.
Yeah, I wasn't gonna
Sorry.
claim
okay.
I was
sorry. I got it. I got it.
thinking
wrong.
I'm getting away with something. Alright.
No, some people just filling in because there are 2 slots.
No.
Okay. All right.
Let me ask the dean how he wants to deal with it. Because in the past,
Should I go talk to the dean? Because
sometimes
this will also be like a really easy A class for me. Like this will be good for my GPA, which I need help with. So
you could consider, if you already know how to program, you could consider credit by exam.
right.
And you can do it at the end of the semester. In other words,
But that would also
don't
give me a
take it.
C.
it will
wouldn't
give you a
Or is it
pass, no
pass, fail?
pass. It's a pass, no pass.
Okay.
Check up on that to see whether it's going to be a letter grade or just pass, no pass. If it's pass, no pass, I don't think it changes your GPA. It doesn't change, it doesn't add to it. So in other words, if you have a GPA of 4.0, okay, and you take a whole bunch of classes with pass, no pass, you should still have a GPA of 4.0.
Interesting.
That's
okay.
my understanding, okay? In other words,
Okay,
pass,
so,
no pass.
so basically I should go talk to my counselor.
Talk to your counselor about
Okay.
the option of credit by exam. And if you go by that option, you're still welcome to come to here. In other words, you'll still be in, you will have your own section number if
Okay.
you do it by credit by exam. So you're not officially in this class, but I will still be happy to add you to the class so they can do the homework. You can still use the first exam and second exam as practice.
Okay.
But the final is your only way to pass the class.
Okay.
Okay, is that making any sense?
Yeah, that's
So
fine.
you're sort of in the class, you still have to pay for the units, except
Of course. Right.
that you're only getting your grade or passing or no pass is determined only by the final exam.
Okay.
And normally you cannot attend the class because you're officially actually not in this class, but to me, as long as there's room and you're not taking the spot of somebody else,
And not being a fire hazard.
not being a fire hazard,
Yeah,
okay,
yeah.
I know a guy with a t-shirt that says, do not set self on fire. And he turned out to be the guy who tuned my car.
No
Yeah.
way.
So, so as far as I'm concerned, you're welcome to, attend the classes and do the homework and participate in first and second exam. And then at the end of the semester, I'll give you your final exam, which is going to be about the same in terms of difficulty level as the rest of the class. So that way, if you decide not to show up and say, well, I know this stuff already, I'll just show up, on the day of the final, do that.
Okay.
If you want to say, well, I got nothing else to do, I'm on campus already, I just want to make sure that I can pass this class, come to the lectures. It's up to you.
All right. Could I get a final exam from a previous semester
Yeah, you can.
and just try it really quick?